Across Ghana, rivers once full of life now flow brown and lifeless, poisoned by greed, choked by mud. But this isn't just about water. It's about science, survival, and the future of every child who lives near these waters. The story begins not in a lab, but in the field. To extract gold, some miners pour mercury into rivers. It pulls gold from rock and leaves death behind. But what if chemistry could undo the harm it's caused?
Let's start with what miners often use to trap gold during small-scale mining. Mercury. Mercury, symbol Hg, a unique element on the periodic table, is a silvery white, heavy D-block metal that is liquid at standard temperature and pressure. It is known for its high density and its historical use in thermometers and barometers, though its toxicity has led to reduced usage. It looks smooth and shiny, but once it enters rivers, it becomes deadly. In water, mercury transforms into methylmercury, a toxic compound that builds up in fish, spreads through the food chain, and damages the brain, kidneys, and nervous system. Its toxicity is even worse in acidic water. That's because low pH conditions make mercury more mobile, allowing it to dissolve and travel farther in the environment. In some mining sites, another chemical is also used, cyanide, especially in large-scale operations. Cyanide is often mixed with water as sodium cyanide to dissolve gold. This makes the water highly alkaline at first. But once exposed to the environment, cyanide can degrade, and if the water becomes acidic over time, it may form hydrogen cyanide gas, which is even more toxic and deadly. That's why testing the pH of water is so important. The pH scale tells us how acidic or basic water is, and dangerous chemical reactions can happen if pH levels change. Clean drinking water should fall between pH 6.5 and 8.5. Outside that range, metals dissolve faster, and toxins like mercury and cyanide become more harmful. So, when we test pH, we're not just checking numbers, we're checking whether conditions are safe, or setting the stage for danger. Fortunately, chemistry doesn't just warn us, it offers solutions. Borax, also known as sodium tetraborate decahydrate, is a white powder made of sodium, boron, and oxygen. It can replace mercury in gold recovery by lowering the melting point of gold without releasing poison into rivers. Already used in parts of the Philippines, Tanzania, and Zimbabwe, borax is a much safer alternative, with no long-term damage to water or aquatic life. This lesson isn't just about elements and compounds, it's about how chemistry helps us see danger, understand it, and fix it before it's too late. In the mining regions of Ghana, rivers once clean and full of life now run dark with silt and poison. Mercury, used by small-scale gold miners, seeps into the water, silently harming fish, farmland, and families. The damage is real, but so is the solution. Across the world, from Tanzania to the Philippines, miners have turned to a safer method: borax. This simple white powder replaces mercury in gold extraction, protecting both water and workers, while increasing the amount of gold recovered. When mining runoff is slowed through sedimentation basins, low-tech ponds built with local materials, mud and heavy metals settle before reaching the river, letting cleaner water flow back into the earth. In communities where science is placed in the hands of the people, students and farmers are testing their own rivers. With basic kits, they check for acidity, turbidity, and contamination, watching their water like guardians, not victims. And when trees are planted along the riverbanks, the land begins to hold again. Roots grip the soil, erosion fades. The river learns to run clear. These aren't just ideas. They're real, tested actions, grounded in chemistry, driven by people and proven to work. With knowledge and will, Ghana's rivers can live again. This is not just science. This is survival. And it starts with us.
Today's project work is a very simple one. As a student scientist, let's figure out how clean our local water really is. Use your knowledge in chemistry to test its pH and check for any harmful ions. Then, get hands-on and build simple water filters with sand, gravels, and charcoal. Compare your results with your friends and discuss how chemistry is key to saving our water bodies. You can also share your data in the comment section. This is KokoChem Education YouTube channel. Always remember that practice makes permanent. So when you watch any video no leave a comment. I would love to hear from you. Share it with a friend and please subscribe. See you in the next video. Thank you for watching.